Okay, in the part 2 of the video, let's start looking at the dynamic memory allocation. Now in C and C++, there are three types of memory that are used by programs. We have already discussed this in the class, and I'm just going to revisit it again. So you know that the memory is partitioned into two different segments. First is we have a text segment where the code or the instructions are stored, and the second part is the data segment. Now the data segment is once again divided into three more parts, which is the static segment, the heap, and the stack. Now the stack segment stores the local variables which are declared as auto. Also the function parameters which we use are also stored in the stack memory, and in the class I've shown you an example of how the stack operations are done on this memory. Now we have another set of data which can be generated by the programs, which are static variables. Now I told you that the static variable has got a file scope. That means it can exist in that file. Now the static variables are also stored in the static part of the memory. Even the global variables, which can exist for the entire file as well as in another file, they are also stored in the static memory segment. So overall we have three data segments: the static memory, the heap memory, and the stack memory. Now in the heap memory you have only those data which are dynamically allocated. Now how can the data be dynamically allocated? In C you have two methods, calloc and malloc, which you have already done. These were used to dynamically store any data into the heap. Now in C++, we will see exactly how an object or a variable or an array can be stored into a heap using two operators. One of them is called as new and the other one is called as delete. Now another thing that I would like to point here is when you store any variables in the heap segment, the variable does not have a name. That means that variable that is stored in the heap is always accessed by an address. That means we need to store the address of that variable in a pointer, and that variable can be accessed only through a pointer operation. Right? Now the heap memory is also called as a free store. So with this concept, let's move ahead. Now I'm just going to read this, which I have just discussed in the previous slide. In C, functions such as malloc are used to dynamically allocate memory from the heap. In C++, this is accomplished using the new and delete operator. Now, how does the new operator work? So what the new operator does is, it allocates memory for an object or a variable, and what it does is, it returns an address of that memory location where that variable has been allocated. Now what we need to do is capture this address in a pointer variable, right? So this is very important. Now when the work of that variable in the heap is completed, we need to deallocate it, in the sense we need to remove the address from the pointer variable which is storing that address of the variable. So in order to do this, we use the delete. So new and delete are two keywords which we are going to use to dynamically allocate memory in C++. And new and delete are keywords and they are the operators. So let's just go through the new operator, which I discussed just some time back. Now I'm just going to read this out. The new operator is used to dynamically allocate any object or an array on a variable into the heap in C++. If memory is available, right, then it will allocate and return an address. However, if the memory is not available, then the program will terminate with an error. Now the dynamically allocated variable or an object will exist in that memory location until we use a delete operator to destroy it. Now this is very important. So the new operator allocates the memory on the heap and the delete operator destroys it from the heap. Now whenever you use a new operator, it's also important that we must destroy the allocated memory using the delete. So a combination of new and delete is used. As a good programming practice, whenever you initialize a memory into initialize a variable into the heap, you must also remove it when the work is completed, and that is done using the delete operator. So let's look at how the new operator actually works. Now, the first line where the arrow is pointing here, we have a pointer variable which is of the type character. So what it is going to do is, it is going to point to an address in the memory which will be holding a value of a character. So in the first step here, when we declare a character pointer, a memory allocation is done for PTR, which has the address 2000. Now this address 2000 is, we are just assuming it as an example. Now what happens next when it comes to PTR? So now look at the first time we are actually using the new operator here. How do we use it? So new operator is going to allocate a memory for a character, and it will return the address of that allocated character and that pointer which we have declared on the top, that pointer will store that address. So if you look at the diagram here, this is the memory allocation done, right, for the new character. This will have an address which is 5000. This 5000 will be stored into the PTR here. So PTR will actually be storing 5000, which is the address of the memory location which is allocated by the new operator here. Now what we do, in order to access this memory location and either insert any value to it, we will be using star PTR is equal to B. Now you know that this star PTR here, we are using it as a dereference operator, right? If you want to find out the address of an variable, we use the AND symbol, the ampersand, which is called as a reference operator. But what is the reverse of it? If you want to find the value of that address, then we use the dereference operator. And you are all familiar with this usage of dereference operator here, right? Now if I want to print a value at this memory location, so if I want to print the value at that memory location, what I need to do is I need to use a cout, and again I need to use a dereference operator to access the value at that address which is being pointed or which is being stored using the pointer variable PTR. So I hope this is clear. This is very simple, and you can just go through it, and if you have any doubt, we will clear it in our live session on Zoom. So what's a delete operator? I've already explained it to you, but we can just quickly go through this. The object or array or a variable currently pointed to by the pointer is deallocated, and the value of the pointer is undefined. That means whenever we are done with using the variables which we have initialized onto the heap, we use the delete operator. So what happens is, the delete operator, we just remove the pointer's address. So if there is a pointer which was PTR in the previous example, the PTR was holding the address of the memory location where the value was allocated. We just clear out the address of PTR. So when you clear out the address of PTR, the pointer to the released memory, we set it to null, right? So let's look at a simple example of how that is done. Now this part of the code, or this part was already discussed before. So all we do is we add a pointer. What we do is we delete the pointer. So delete is the keyword. So once our work is done, we have printed the value at that memory address which was pointed by PTR. We just do a delete PTR. So when we do a delete PTR, what happens is this value 500 the 5000 is removed. So once this is removed, PTR will have null value and this connection will be lost. So as soon as you have a connection which is lost, then this becomes a perfect candidate for the garbage collector to come and clear it off. So the garbage collector will see that there is a memory location which is not, just go back to the slide. Yeah, there is a memory location which is not referenced at all. That means it is this, if we delete 5000, then this connection will be lost. So if you find a memory location which is not referenced, then the garbage collector will come and clean it off. So this is how the new and the delete operator works. Now before we move on to the next topic and see exactly how you can create an object using the new and delete operator, I would like you to revise through this concept that we've discussed, because we need to go very slow with polymorphism. Every slide is important here. So you make sure that you understand each and every slide before you move to the next one, because it's a very simple and a delicate topic, but we need to have an understanding in terms of conceptually. In terms of conceptual knowledge, we have to be very clear about what polymorphism is. Now before I move on and start explaining polymorphism using an example and what exactly is the virtual functions and the different properties, you please be clear till this slide of how we can allocate an object by using the new and the delete operator. So the next part I will continue in part 3, but before that we will meet again on Zoom class and we will clear all your doubts which you have. So please go through it very carefully and I'll see you again soon. Bye.